let's talk about part 2 of reinforcement learning and traffic signal in SUMO. And then that's developing two reinforcement learning algorithms, Q learning and deep Q learning. I just noticed that around 90% of visitors in the channel uh, has not yet subscribed to the channel, and then uh, it will help me a lot to create further videos for you. So make sure that you subscribe the channels. Thank you very much for that. So moving on, I highly recommend students or researchers, people, you know, uh, to use this guideline for their report projects. So this guideline is on the right side, uh, is a traffic analysis toolbox developed by FHWA, Federal Highway Administration in US, which is a pretty standard in this regard. I saw many companies, industry, and governmental sectors are using these 7 steps to do any types of microsimulation work. So we are following these 7 steps. So the first step is a microsimulation analysis plan. Okay, so that step we are talking about the goal and objectives and study area. So for our case in this tutorial, the goal and objective is developing two reinforcement learning algorithm and compare the results with the static traffic signal. And the study area is just random intersections, but I highly recommend you to use uh, real world intersections. There are some videos already in the channel that you can pick a specific corridor or intersections in your city and then create the intersection on top of the GIS map. Okay, so the next step here on the right side is the data collection and analysis. So what's the required data for our tasks, right? So the required data is the traffic flow parameters, traffic volume and speed, and traffic behavioral parameters, lane changing model, car following model, and the vehicle types. So for all of these, I'm just using the default SUMO values for the sake of just tutorial, right? But I highly recommend you to use some sort of open data for traffic volume, and then at least talk about this lane changing model and the car following model, because these are the fundamentals of the simulation in your report, in your thesis, right? And also the vehicle type. So for these two, I already covered another video in the channel. You can find it and then use some of those languages. Number three. Number three is the required steps for creating the network. And then this is, I think, the most important part of this tutorial. So these are the steps, sub-steps per se. Create network, name it properly, adding traffic cars, vehicle types, detector, and then traffic light. So, okay, so now we are jumping to the simulations, and then we're gonna create this type of networks and then name the network as you can see. For example, node 1 and 2 is node 1, 2 westbound. So this road should be called like this, okay? So let's jump to the simulations. Then search here, netedit, and then here, new network. And then zoom out a little bit. And then I'm just changing this number of lane to 3 for now. And then creating a simple network, like what we saw in the PowerPoint. Okay, if you see this, I am just Control Z. I just want to have the intersections without any. And then press F5 or simply go processing compute junction. Okay, so now select this link, select all of them, because this is just one-way roads now. I want a two-way. And then right click edge, add reverse direction for 8 edges. So it will add the reverse directions, right? So right now, just press, if you press escape, then it will deselect all of those blue links, right? So now I'm just putting the PowerPoint on one side and my network on the other side, and then a little bit zoom in this. Okay, so first of all, click on this magnifier and then call this node 1, in node 2, this should be node 3, node 4, node 5, node 6. Okay, I made a mistake here. This is node 4, node 5, and this would be node 6. And okay, this one is a little bit tricky. So make sure that you select, you should not select the edge, you should select the junction. Node 7. Okay, now let's just call these roads. The naming is very important because later on we will call these lane names in TraCI, right? So this would be node 1, and this is hyphen. If this is not underscore, so I'm just using the same languages as the programmers are using. So before moving on, I'm just saving this. So that's the mistakes that a lot of people are making usually, to not save the, I'm just putting the name as RL and then RL. Yeah, I just suggest to save your network even from the start. And then this one should be node 1, 2 again, 2 westbound, and then this is the node 2, 5 southbound, right? And then this one is node 2, 5 northbound, node 2, 3, 3 eastbound. Okay, this should be hyphen. I mean, everything is based on the programming language. We normally use hyphen rather than the underscore. So that's the pretty standard thing in programming. Southbound. Okay, so now I'm gonna save the network. So we called all this because the intersections that we are gonna do reinforcement learning on it is this intersection, node 2. So then we don't need to name the rest of the networks. So I'm just moving on to the next. So next one is adding traffic, cars, volume, speed, right? Again, I'm putting this here, going to the demand. So the vehicle types is default. So I'm just using the default one. Change this trip to flow. And then the first is starting from here, here, then going here, then here. The traffic volume is, I'm just using the normal, the default one. And then here is from here, going down here and then here, right? You can change the ID and everything. I mean, I'm just putting everything as a default for the sake of the tutorial. Okay, so just save everything again. So this time we have a root file, which is the root basically. The next slide. Okay, so now we're gonna add detectors. So for the detectors, this step is adding the detectors, the lane area detector. I suggest you to read this, and also we're gonna use the TraCI, okay, and then for the detectors there are some value retrieval and then state changing. So we're gonna use the value retrieval for the detector, which is the lane area, right? And then what we are gonna get from the SUMO here is last step vehicle number, which is the number of vehicles that have been within the area within the last. Okay, so this is the functions that we are using. So this is the thing that we are reading from the network. Okay, so let's add these type of detectors. Again, go to the SUMO. Where is SUMO here? And then, so for the detectors, you need to put it network, and then this H, I'm not sure, like that's additional. And then here add lane area detector, and then the ID, just use this ID for this one, because the name is coming from, if I wanna tell you, is if you go here, select this magnifier and then select this lane selection, then this lane, the ID is this node 1, 2, EB, and 0. It starts from 0, 1, 2, and then 0, 1, 2, right? And then this prefix is the same as the name of the streets. So we are using the same naming for putting the detectors. Okay, so here this the name of this detector, right? And then I'm putting here, okay, a little bit maybe. You can play around with these detectors later on to put, so the way that you can play around is using uh, these positions. So you can change these positions and then the length of the detectors, right? Usually it should be longer than 10 meters, but I'm just putting everything as defaults. Just fixing the names very quickly. Okay, I didn't change this one, I guess. Okay, and then one more thing is we didn't change this here. This should be 1, then this should be 2. Sorry about that. Like, okay, so it gives error. You need to exactly write the, yeah, because there should not be empty space. Yeah, it's good to have that error so people might get confused later on. I'm just saving this as a RL, and then this one is just, yeah, remove all of those empty. And then here we have, again, this time I am just putting this naming very quickly. I mean, we are forced to do it because later on we want to read this from TraCI. That's why we need to put a lot of times here. Okay, so we are done with the detectors, and now we're gonna add the traffic lights. So for the traffic light, we have 3 scenarios: fixed timing, Q learning, and deep Q learning, right? And then again, for the traffic light, if you go to the again TraCI, and then there is the infrastructure traffic light value retrieval, right? And then we are getting this get phase, current phase of the traffic light, and then we will change the traffic light state using this set phase. So these are the functions that we will use in the Python TraCI. Okay, for the traffic light, again, select this shape traffic lights here and then click here, create. The traffic light name is by default the same name as junction ID, node 2, and I am just keeping the same. And then as you can see here, these are the phase as I mentioned in the part 1, and then these are green, 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 red, 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 right? So one exercise that you can do here is go to the edit visualization and then into the junctions, show this TLS ID. So it will show you 0, 1, 2, 3, 4, right? So these are the 0, 1, 2, 3, 4 for green, right? It's already green as you can see. And then after that, these numbers matched with these states here. Next is now we have 3 Python codes, right? And before uh, before running it, make sure that what's this? Just okay. Okay, I think we lost the file somehow for this fixed signal. I'm just quickly go here and then copy paste again the TraCI number 5, which is this one. Okay, so here before running, we need to first make sure that we have this library. Okay, so for that, go here in the Visual Studio Code and then here click here, no problem. And then in the terminal, search here pip list, then make sure that you have the TensorFlow, right? And then the what's the next one? NumPy and the matplotlib. So these are the thing that you need to have. If you don't have, then just write, just install pipe. What was the code? Install NumPy, install NumPy, something like this, and then press enter. It will install for you. Okay. So yeah, so those are the libraries that you need to install. So before running it, maybe we can first run it, because normally is just run to see if I'm just running it, make sure that okay, it doesn't run. So let's say this error is good because we can understand what's the problem is, you know. Yeah, so the problem is maybe the namings of these detectors. So let's say okay, so let's go to the network and then double check the namings first, and then I will explain. Yeah, so that naming is for the detectors. Yes, so as you can see, this is the problem here, and then this should be node. So if I go back here in the PowerPoint, this is node 2 and node 7, right? So then these detectors, these are not should be node 1 and 2, right? Node 2 and 7. I mean, these errors are good because later on you will face also these type of errors, right? So you can understand that how these namings is important now. and then save it. Save everything here, the icons. Just click on it and then run it. Okay, so perfect. So let's put this here, and then this sumo is here. As you can see, we have now some informations here, right? So I'm just stopping the simulation, and then you can see at each steps we have a couple of informations here. Okay, uh, so let's go back to the PowerPoint first, and then we were here, right? Okay, so we are running an optimization model, right? Those who might already familiar with the optimizations. Usually, normally in optimization, we have an objective function and a couple of equations, right? So same thing. So we need to code that, right? So this is the Q-learning algorithm, if you remember. And then in max reward, right, we have two equations, equation number 1 and number 2. So these equations means that we wanna maximize the negative Q length, right? Or minimize the Q length. Basically, we need to decrease the Q, right? And then number 3, 4, 8, which is the state, right? So using these two equations, we are getting the state of the detected vehicles and the traffic lights from SUMO, okay? And then, of course, those numbers like Q and then the phase should not be uh, negative value, right? The Q is positive also. Q means the Q length, right? And the phase number is, as we talked already, 0, 1, 2, 3, right? And these are the phases, the variables we call it. And then there is a number 6 and 7, which is here. These are the for Q learning. So later on, when we are changing the algorithm to some sort of neural network or deep Q learning, right? So we need to change this part, only this part. That's it. And then the actions is switching, and this is the action number 5, the equation number 5, switching or not. Okay, so then okay, let's talk a little bit about the Q learning. Again, assume that we call these detectors and 1, 2, 3, 4, 5, 6. Forget about this. I mean, here we call it as a 0, 1, 2, right? This is just for programming. But right now, this is just for understanding right now, okay? So, and the results. So this is 1, 2, 3, 4 to 6. Okay, so now this is kind of output, right? So I'm talking about the Q learning and then how the algorithm works. So assume we are in step 630, right? So which means that, for example, 630 iteration has passed from the SUMO, right? And the current state is this 2, 2 means that 2 means that these two detectors have two cars. Detector number 3 has 0. Detector number 4 and 5 has one car each, and number 6 has 0. The phase is 0 of the traffic light. The action that the algorithm would take is 1. Then the new states then is the current state, but the action is just 1, changing 0 to 1, right? And the reward is -6. How? Just summations of all of those detected cars. 2, 2, 1, 1 is 6, right? This is the cumulative rewards over the past 630 steps. There is a Q table. There is Q values, right? In Q learning algorithm. So this is Q learning updates functions, as you might observe here in the slide. The Q learning update. This is the most important equations for the algorithms. So how it works, just read. You can pause and read these informations here, or copy paste this into the chat GPT and then just ask. Just explain Q learning, how it works, right? So right now we have a Q tables, for example, right? Because this algorithm needs to take an action based on what? Based on the previous observations, right? So the previous observations say between 0 and 629 that whenever the state is 220110, then this is the reward, the expected reward. The action 0, if you take, then the expected reward is minus 0.6. If the action 1 you take, the expected reward is 0. Then which one is better? Of course, the 0 is better than minus 6 because we want to maximize it, right? Okay, just go through this and then understand how the Q tables and Q values work. These two numbers, we call it as Q value, and then these numbers here, we call it as the Q table. Okay, so right now, for example, we run the algorithms right here, and there were some steps, right? So step 89, again, these are the cars, detectors, traffic phase, action, and reward, right? State, action, reward. And then the Q tables. So in each step, we have the Q tables and the Q values start generating. So if I am showing you these results, now you can observe that I go a little bit top. So when the algorithm starts, right, it's step 0. This is the current step based on the detector and then traffic phase. The actions that it would take, right, and then the Q tables. So as you can see, the Q table is just one row because there is no data, right? But as it goes down, right, now the Q tables would be, for example, 4 rows. And then these are the Q values that it updates. Okay, the deep Q learning, just assume everything remains the same, okay? The only one that we are changing is number 6. The equation number 6 would change to this, which is deep Q learning, okay? And then this is how you can visualize it in your thesis or your report. The input layers, we will have 6 detectors and then the signal phase, right? The output is those 2 actions. Then in the between, we have some neurons and hidden layer, right? And then I am using this activation layer as a rectify and loss function, and optimizer is Adam, right? And then this is the reference that you can use. Maybe you can just zoom a little bit. Okay, so I'm gonna explain a little bit of this code for you so that you can also understand what this code means. Okay, what I'm gonna do is just stop this and then open this deep Q learning as well, and then select this one here. So now I have the deep Q learning here and the Q learning here. As you can see, there are some, first of all, we prepared a template in TraCI quick start video in the same channel. So the template for using the TraCI contains 9 consecutive steps, right? And then among these steps, as I said, you don't need to change the steps number 1 to 5 and step number 9. The only ones that you need to modify step 6, 7, and 8. Okay. There are some extra spaces here. I put it intentionally to match this code and then this code. Let's say step number 6 is in line 37. Step not in another code. This is different code, by the way. On the right side is in the same line, right? I go down and then, as I said, for example, this one, get Q length, for example, is 197, right? And then as you can see, the same equation is here in 197. So you get the point, right? So these extra spaces is the same. For the fixed timing is 2. I mean, same thing, 179, 97. Okay. So then, right, then the question is how you are writing these equations or changing this equation to these codes, right? So I'm going to close this one and then explain you. As I said, you don't need to change the first 5 steps. Okay, this is very important. The RL is the name of SUMO CFG file here. So whatever the name is, you need to match it here. And then the step length is 0.1, which means, for example, if we are talking about a step 120, multiply this by this value will give you the simulation seconds, which is second 12. Okay, so then coming down, I'm talking about these functions. These functions on the right side, we are changing to the codes on the left side. Okay, so let's say number 1 and 2 is, this is the objective function, number 1, and this is number 2, rewards. Number 3 and 4, we are writing here. Number 5 and 6, 5 and 6, 7 and 8, 7 and 2 8s, right? So if you remember, I told you that the variables get from SUMO, right? What we want to get from SUMO, you remember that? It's first the traffic light phase, right? Second, the detected cars in the detectors, right? So those two now we are getting from SUMO here. Get Q length, which is the detector ID, and then that vehicle number, if you remember, right? And then get phase. So these two are those two variables that the information from SUMO that we fit to the TraCI for based on these equations, right? So now in deep Q learning, as I said, the only things that is changing, okay, is number 6. So you need to go here. Don't be confused about step 6 and number 6. What I'm saying here is inside the functions, not here. This is the templates, right? And inside the functions, where is number 6? So number 6 is here. This one, the updated, this one, exactly. We are changing. If you compare the two, right? Step number 6, I'm just increasing the sizes. So it's starting from line 168, right? This one, and then this one, compare. And you can observe that, okay, we are changing something here. And then we are using DQN, deep Q network, right? Or learning. And then one more thing is we need to also build, of course, the deep learning. Not deep learning, it's neural network, right? And then that one is also located here. So that's the another difference between this code and this code. Maybe if you want, just put in the comments that I will record another video explain about these equations and each line of the code, and then how you can, for example, change or play with the code to get the results that you're looking for. For examples here, these are the parameters of the reinforcement learning, right? So these parameters here, you can change these parameters and then get different results, right? So this code is not just a template code. It's not just a fixed code, for example, per se, right? You can change it. You can change many things inside the code. But for that, I need to record another video based on your comments. So then we can safely move to the next. And then one more thing, you can just copy paste this into the ChatGPT and ask each and every steps, right? That how the code is working. It's like a engineer for you, the ChatGPT. Okay,